Hi, welcome everyone. Good evening. I am Erica Piola, Director of the Visual Culture Program, and I'm delighted to be the host of this evening's Fireside Chat with former Library Company Fellow Dr. Brooke Belisle. In her talk tonight, Brooke will be discussing her new book, Depth Effects, Dimensionality from Camera to Computation, which explores how early experiments in photographic aesthetics offer unexpected resources for navigating current transformations in visual culture, so heavily rooted in computer imaging, including on our ever-at-hand smartphones. But before I introduce Brooke and we begin, I would like to note that the chat is about 40 minutes, and there will be time for questions and answers. So please place any queries in the Q&A button on the bottom of the screen at any time during the discussion. I would also like to briefly introduce the Library Company and the Visual Culture Program to those who may not be familiar with either. The Library Company was originally started in 1731 as a subscription library by then printer Benjamin Franklin and his discussion group, the Junto. Today, we are an independent research library for the study of American culture and history before the early 20th century. Our rich holdings include over 1 million books, graphics, ephemera, and art artifacts, and comprise subject strengths such as African American history, women's history, and visual culture. The latter inspired the implementation of the Visual Culture Program with the mission to promote visual literacy through the creative use of historical visual materials and supports exhibitions, research fellowships, publications, acquisitions, digital projects, and public programs. The Visual Culture Program seeks to facilitate talks, such as tonight's, that confront, explore, and complicate the social construction of what we see, how we see it, and why we see it as we do in our understanding of the mass visual culture of the nation before 1950. This evening, I am delighted to host Brooke in her talk about her most recent published work that explores the relationship between the history of photography and the visual culture of today's computer imaging through AI. It is a timely topic as we grapple with the depths, as explored by Brooke in all senses of the word, of our computer-generated world and how we understand it visually, including the visibility, invisibility, hiddenness, sidedness, interiority, exteriority, location, and dislocation between and within pictures. As Brooke notes, such questioning of these aspects of how we see leaves room for other views of seeing. It is now my pleasure to introduce Dr. Brooke Belisle. Brooke is Associate Professor of Art History and Criticism in the Department of Art at Stony Brook University, where she is also affiliated with the Institute for Advanced Computational Science and the Alda Center for Communicating Science. While her first book, Depth Effects, connects emerging forms of computational imaging to aesthetic experiments in very early photography, her current book project, Seeing Stars, Astronomical Media, traces changing techniques of visual mediation in the history of astronomy and astrophysics. Belisle studied 19th century visual culture as a fellow at the Library Company of Philadelphia and has also held fellowships from ACLS and the Getty. Her work can be found in recent or forthcoming issues of Critical Inquiry, LA Plus, and Photography and Culture. Brooke, thank you for joining us this evening. The screen is now yours.
Hi, everybody. Thank you so much, Erica. I should have been visible this whole introduction, but I was told to wait for my cue. So let me share my screen now. I'm excited to see a few familiar names in the attendee list. So thank all of you for coming and logging on so we can be virtually fireside for our chat. And thank you so much to Erica and the Library Company for creating this occasion and inviting me to talk to you. All right, let's get this up. So you've heard about a year ago, I published a book connecting recent AI-driven imaging methods with early experiments in 19th century photography. Since then, a lot has happened. This is the table of contents because I imagine most of you have not read it as a little peek inside. So since this book came out, a lot has happened very fast as AI-driven imaging methods have hit the front pages of all kinds of popular media. And generative AI in particular has raised a lot of questions about the past and future of photography. To anyone familiar with the history of photography, these really recent debates about AI seem to recirculate some very old questions. And of course, anxieties about how images relate to reality are even older. But new forms of visual mediation definitely recast these anxieties and these questions in changing ways. And it did and does seem to me that visual techniques structured by machine learning do operate in significantly new ways, and they are shifting norms of vision and representation. So, to understand the stakes of this, I wanted to resituate it within a broader history. So I looked back to the emergence of photography in the 19th century to think about how norms that AI now seems to displace were once being established, and this earlier period of transformation in visual culture and how it might resonate with ours. To find a different through line for rethinking visual aesthetics between then and now, I chose to focus on the problem of mediating depth. So, photographic and algorithmic visual media are often referred to as time based and have largely been understood that way. Histories and theories of visual culture have emphasized photography's capacity to freeze and index an instant, cinema's capacity to mobilize stills and render duration, and digital media's anticipatory logic of pattern recognition and prediction. But in the phenomenological frameworks that subtend much of this theory, spatial depth and temporal duration are interrelated expressions of a more general dimensionality, a thickness that stretches between now and then and between here and there. Physics agrees with phenomenology about this paradox, seeing space and time as expressions of the same self differentiation of existence itself, how anything materially takes place. In depth effects, my concept of depth is in direct conversation with the work of the 20th century philosopher Maurice Merleau-Ponty. One heuristic he uses to think about depth is a cube. So a square becomes a cube when a third dimension of depth is added to height and width. That depth pushes one side of the cube away as the back or the bottom, behind or beneath another side that is the front or the top. If you're looking at a cube and not a line drawing of one, you can only see the sides that you face or the faces on your side. But you grasp a depth you can't directly see just by understanding it as a cube. The figure I'm showing you now, a Necker cube, also helps illustrate the contingency and instability of dimensional relationships and depth effects. If you stare at it long enough, the lines will seem to pop between two possible organizations to create two different cubes. Merleau-Ponty argues that this is not an illusion, but a genuine paradox that just usually eludes us because our sense of dimensionality involves us and appears given in ways that are just difficult to destabilize or reorganize. What appears, in other words, as the objective depth of a cube requires a broader organization of space that positions the viewer and shapes their view. So, in thinking about depth, I'm asking how changing ways we visually mediate space both presume and posit how things show up as visible and appear self structured in the very way they seem to already take place. Part of my argument in the book is that dominant logics of visual representation, the media aesthetics of any particular moment, condition how fundamental forms of relationality appear self organized, how something seems to hold together as itself, how things stand apart, how inside and outside, front and back, and here and there seem self evident. Depth effects can be produced through specific technical and aesthetic strategies, but they're also broader shapes of seeing and knowing, expressions of visibility and power that become naturalized in spatial and material ways. The book has three core chapters with more theoretical riffs interlaced between. Each chapter takes up an example of popular visual culture to explain a spatial technique of computational imaging that uses AI and has become entirely dominant. These are widespread ways that machine learning and computer vision intervene in and alter everyday practices of seeing and representing. So like object recognition, like photogrammetry. To understand not just what's new about these techniques, but why that might matter, I turn back to the 19th century and reconsider the photographic norms that they seem to extend or break. By shifting away from how we focused on just single photographs and questions of temporality, and instead looking at spatial strategies for relating photographs, I find unexpected precedents for recent imaging strategies. And I try to ask how what was at stake then when these strategies were first experimented with might still be at stake now as these ideas are resurfaced and reorganized. Coming back to the present to end each chapter, I look at lens-based work by contemporary media artists, and I ask how they explore dimensionality against the grain of conventional photography and computational norms. I'm thinking about how their work can help us remember both the problems and possibilities that carry forward from lens-based through algorithmic forms of mediation. So the first chapter of Depth Effects is titled The Sightedness of Things, Object Recognition and Computer Vision, and it begins with chihuahuas and blueberry muffins, part of a viral series of memes about animals that look like food. I hope you remember it. If you don't, you better go look it up. These play at the process of object recognition and appeared at a moment when computer vision techniques were reaching a tipping point as machine learning made it possible to use massive sets of photographs to train algorithms to identify things in images. It feels very humanly humorous to see the similarities of lumpy muffins and little puppy faces. But this is also playing back and forth between a human way of seeing things in images and a machinic way of comparing pixel arrays. For computer vision algorithms, dogs and muffins are just different ways of arranging dark dots inside beige blobs. I explain in this first chapter how processes of deep learning extract patterns from images to define visible things in terms of mathematical probabilities, predicting relative positions of pixels in a coordinate plane. This both leverages and breaks away from the ways that we tend to understand photographic representation. But I argue that it reinvents some early ways of trying to extract spatial information from photographs. I show how stereoscopic and serial techniques in early photography point to an alternative genealogy linking lens-based and computational imaging, which has always emphasized relationships between images rather than the indexical referentiality of any one image. And I revisit ways that photographs have been juxtaposed to visualize depth and volume, from stereographs and motion studies to the elaborate process of photosculpture that made three-dimensional busts from wraparound images. And Michelle, if you're still in the group, I think you were the one who first tipped me off to this. I also look at industrial time and motion studies that worked to model and optimize shapes of workers' gestures, and early work in facial recognition that defined features of a face in topographical relief. Leading up to these early steps in computer vision that were building the ImageNet dataset, which promised to capture and categorize the entire visible world for systems of object recognition. So moving through this lineage from early photography through how these groups of images are used to train the spatial properties of object vision, I end with the work by the artist Trevor Paglen, who I realize now has become, the poster child of art about AI. But I'm interested in specific series of work of his and also with one of his collaborators, which take up and use as found objects the image sets that are used to train computer vision. I show how this work challenges viewers to grapple with algorithmic processes that are incompatible with embodied perception and can't be made visible, but are restructuring what now counts as visibility. And I argue in this whole chapter that the problem with computer vision is not just biased data sets and a need for more complete representation, fewer mistakes of misrecognition, but rather that we need to remember we can't extract and reiterate the complete and objective visibility of things, and more that we shouldn't want to, that everything visible shows up from a partial and situated way of seeing a particular perspective, and that's not a problem, it's a good and important thing. So instead of that being a limit to push past, to understand it as a structural condition of visibility is a way that we push back against totalizing ideas of this view from everywhere that's really from nowhere, as Donna Haraway has echoed Merleau-Ponty to point out. These total views that computer vision and ambitious ideas like the data set that will represent the entire world are abstractions that can't have a world and can't really have a viewer. Oh, and I should have let you look at that instead of the blank screen for the last moment. I apologize. This is an installation Trevor Paglin made of images from the ImageNet dataset with some of the labels that those images are clustered around. So if the last clip I showed you from this artwork uses time to help imagine the computational processes leading up to these systems, this uses this spatial array that you wander along, and it is deliberately quite overwhelming. So by the end of the first chapter, I've explained how dimensional information is extracted from photographs to enable the spatial operations of computer vision algorithms. In chapter 2, Surfacing Subjectivity, Portrait Mode, and Computational Photography, I show how these algorithms feed back into the spatial operations of making photographs today, and how they've reinvented photography as a computational medium, or they're part of that. The advent of smartphones caused a radical transformation of photography that we're still beginning to grasp. And the title of the book, Depth Effects, is named after the iPhone feature for manipulating depth of field. You've probably all used this in automated functions like portrait mode, pushing and pulling the background in and out of focus, making things appear closer or farther away. This feature looks like, and even sometimes has f-stop markings that emulate how a photographer might change aperture size and focal length. With a traditional camera, these adjustments involve material spatial relationships, how rays of light bend and gather differently depending on relative sizes and shapes and distances of the aperture and lens and recording surface. But with a smartphone, this becomes a computational modulation, a pushing and pulling of data. It simulates optical adjustments and effects that aren't otherwise possible with a smartphone camera. The lenses on these cameras are so small and the device itself is so thin that there isn't enough range for the aperture or the focal length to adjust. So these depth effects rely on the fact that smartphones are not just cameras, they're computers with multiple apertures and lenses, infrared and LiDAR lasers, and other kinds of non-optical sensors. Like when you do facial recognition with your phone, this happens where the Face ID is shooting dots at you you don't realize. So they also have neural processors inside them that are running powerful AI. When you click portrait mode on a smartphone, it uses computational methods of depth mapping to simulate a photographic aesthetic. And that might involve parallax measurements between multiple camera lenses or lasers bouncing off your face. In this chapter, I think back to the way that depth effects have historically functioned in portraiture and structured other kinds of portrait modes. So I remember how and why shallow depth of field first became a convention in commercial portrait studios, and how it staged an internalized kind of subjectivity possessed by only certain subjects. And I think about, in contrast, how stereoscopic nudes and anthropometric photographs that were also some of the first to portray people used depth very differently to convey the contours of the body, not the soul, and using relationships of surface and depth to express gendered and racialized ideas about embodied identity. Remembering how depth effects have been used to imbue a subject with hidden interiority or to place body and world in the same plane as equally objectified and quantifiable. I ask how the dimensional aesthetics of portrait mode in smartphones reactivates this history and restages its stakes. To explore possibilities for portraiture that complicate oppositions of surface and depth, which of course I am not the first to point out in histories of photographic portraiture. Um, I consider collages by Lorna Simpson that produce disjunctive foregrounds and backgrounds using faces of Black women cut out from vintage magazines. And I look at doubled self-portraits that Latoya Ruby Frazier made with her mother, where a visceral overlap between two people inside the image protects an intimate space from an outside gaze. I argue that portrait mode's automated convention of cutting out the subject and pushing the world away forgets what these artists actively remember, what Merleau-Ponty described as the intercorporeal terms of embodied and enworlded subjectivity. And I consider how the limit of appearing as a thing in an image or as a body in a shared world could be something other than entirely objectifying, how it could be a productive exposure that Merleau-Ponty calls our always unfinished incarnation. So the first chapter considers the objective contours of things. The second chapter explores the subjective depths of personhood. And then the third chapter of depth effects addresses the expansive dimensions of whatever world in common holds all these people and things. The first and second chapters explain how photography has been used to build computational imaging techniques and how these techniques have in turn transformed photography. And the last chapter, Visible World, Photographic Maps, and Computational Photogrammetry, considers how an interleaving of the photographic and computational conditions how spatiality itself is conceived and made visible now, how it's constructed through imaging techniques that are used to map and model physical and geographical space. So in this chapter, I look at AI-driven features of Google Maps, like the AR overlay of Live View, which embeds directional arrows into what look like the actual space around you, and what Google has called its all-new immersive view that allows you to virtually zoom in and out of the map. You used to have to drag poor Pegman by his arm and drop him onto the map to go from an aerial to an embedded view. But advances in AI and computational photogrammetry have made it possible to seemingly fuse these different layers of street view and satellite view and to correlate the spatial model of a map with live camera imagery. I explain how Google uses computer vision and machine learning to extract and integrate data from almost 200 billion images from satellites, street view cameras, and also your live smartphone data. To retrace how we got here, I look back to how photogrammetry emerged in the first efforts to use cameras in land surveying in the 19th century. This incorporated the camera as an optical instrument for spatial measurement, integrated with other optical and mathematical devices used in plane table surveying. So I'm showing you plane table surveying um, that then the camera would be added to this kind of setup. And I think you also had to have a hat. I'm not sure about that part. So these practices did not treat photography as maps or really even as pictorial. They extrapolated spatial information from them by triangulating perspectival relationships between anchor points in different pictures of the same place. I follow these techniques used to translate between actual and photographic space from colonial and national projects in the late 19th century into 20th century forms of stereophotogrammetry, which were essential for wartime aerial mapping and which developed alongside other techniques of 3D that were used in cinema, for example, but worked in a very different way. In stereophotogrammetry, it allowed cartographers to manually manipulate a dimensional image they called a stereo model. To rethink these relationships of maps and photographs, I end this chapter with just one artwork, a massive series of 6 images by Andreas Gursky that's collectively titled Ocean. He made these using satellite data, and they look like high-resolution aerial views, but they're also utterly disorienting. They're perspectively flat, like maps, but with the verisimilitude of photographs. Instead of showing the world of a world map, they show the background or the in-between of the planet's interconnected oceans, pulled apart on different walls. And the singular plural of the title ocean plays with this. Standing in the room with these images, you can't help but try to visualize how they could fit together around you or add back up to a whole, but they stubbornly refuse to. In some ways, this last artwork in the book returns to the book's first image of the Necker cube and that paradox of a dimensional leap that doesn't just sum up parts into a whole. I use it to try to remember why no amount of photographs could capture or add up to the whole world, and why maps and photographs are so different despite how they are increasingly fused. As with earlier chapters, I come back to the embedded and embodied conditions of visibility, and in this case, what it means to be part of a world that's more than a picture. I argue that the perspectival limits that make it possible to use photographs for photogrammetry also point beyond the concatenation of any totally visible place toward what Merleau-Ponty calls other landscapes. These other landscapes aren't always just beyond the horizon, but they open as other ways of seeing and being right where we are. And my one big disappointment with how the book came out is the images don't show these beautiful swirls, the nuances of the blue color. So I hope that anyone who reads the book will look up these images or see them in person and see what is missing from the reproductions. The book I'm working on now continues to explore photographic and computational mediations of dimensional relationships and space. But now I'm going out from Earth to outer space. And this project is still finding its shape, but it moves from ways we've tried to bring the moon within reach to how photography was used to map the stars and resolve the mystery of nebulae, and how computational simulations today are used to model exploding stars and map the overarching structure of the cosmos. I've been very privileged to learn about this through collaborating with a colleague and his research group in computational astrophysics at Stony Brook and the Institute for Advanced Computational Science. And I've been catching up on all the science I worked so hard to avoid as always a humanities major and PhD student. Part of what matters to me in this project is rethinking relationships of depiction and quantification, art and science, lens-based and algorithmic structures of seeing and knowing. But I'm also interested in finding another context for what feels like a current crisis of evidentiality, a way that the rise of AI seems to correlate with a broader destabilization of how we create and ground consensus and agree about what's real. Debates about how to interpret the first long exposure photographs of deep space, arguing whether a nebula that seemed to be there was real or an artifact of the photographic process, for example, are arguments about how visualizations made from computational simulations relate to any actual thing. These changing forms of aesthetic mediation and shifting relationships of seeing and knowing correlate in the history of astronomy and astrophysics with very profound reconceptions of our material reality, changing ideas of what the universe is at all. the universe went from being just the Milky Way to including countless other galaxies, for example. And that didn't really happen until the 1920s and crucially required photographic archives to be able to do that. So I think there could be lessons in this visual archive and in these aesthetic practices of astronomy and astrophysics because they're related so explicitly to the real. For a pretty dizzying situation, it feels like we're in again. So I will stop there, and I would be happy to talk more about. Oh, the slide was out of place about the mysterious nebulae that will mislead the inexperienced in stellar photography. I'm happy to talk more about this current project or the book or anything else. But I also want to end by thanking Erica again, um, because she taught me an enormous amount in my time as a fellow at the Library Company of Philadelphia. So you might be surprised that there are not so many panoramas in the book, Erica, that it seemed like there would be based on what I came there to study. But part of the reason for that is that my project really shifted through the research I did and through things Erica really taught me by expanding some of the temporal purview and some of the material examples I was looking at, which showed me some of my theories were wrong. And so there's it's important what's not in the book too. That I think Erica helped me move away from some things that I'm glad I moved away from. On the other hand, there's a lot still left at the library that I haven't gotten a chance to write about yet that I'm still hoping to come back and work on some more and will be the seeds of future projects. So I know the other people who've been fellows there that are in the group too, all share my appreciation for Erica in particular and for the support that these fellowships offer. So thank you very much for that.
You so much, Brooke. This was great. I think it's a little before 8, so so I think we end here and let folks get on to their Thursday. But this was such a wonderful conversation, and I just just love the seeing stars and understanding your title and that disorientation and that wordplay, and like I said, the other wordplays in your current book. But thank you for spending this time with us this evening. Like I said, I really great conversation. Thank you for everyone who joined us this evening, and I hope some of you will come back for some of our other library company virtual events coming up that you saw in the opening slides. And yeah, so everyone have a really wonderful evening, and thank you again so much, Brooke. This was really wonderful. Thank you.
Thank you, and thank you, people in the chat. Let's catch up elsewhere. Other firesides.
Everyone. Yep. Have a good evening. Thanks, everyone.
Bye.